Somewhere in the vast darkness above us, there's a star exploding, a planet forming, and maybe, just maybe, life evolving. Space isn't just big, it's mind-bendingly bizarre. But what if I told you the universe is doing things right now that would break your brain? From invisible matter to stars that could eat our sun for breakfast, this video will take you on a journey through the weirdest corners of the cosmos. Get ready to have your mind blown wide open, because we're about to explore 10 space facts that sound like they're straight out of science fiction, but I assure you, are very, very real. Let's blast off. You might think astronomers have a pretty good handle on what the universe is made of. After all, we can see stars, planets, galaxies strewn across the cosmos like dazzling diamonds on a velvet cloth. But here's the catch. That dazzling display? It's just the tip of the cosmic iceberg. Everything we can see, all the glittering stars, swirling galaxies, even the planets in our own solar system, makes up a measly 5% of the universe. Think about that for a second. Everything we've ever observed, every bit of light that's ever reached our telescopes comes from a tiny fraction of what's actually out there. The rest, my friends, is a mystery. We call it dark matter and dark energy, not because they're evil or mysterious, but because they don't interact with light the way normal matter does. We can't see them, touch them, or even detect them directly. Yet, we know they're out there, lurking in the shadows, holding the universe together. How do we know if we can't see them? Imagine a ghostly hand shaping a galaxy, its influence visible in the way stars move, but the hand itself remains invisible. That's dark matter, shaping galaxies, bending light, and dictating how the universe evolves. It's a cosmic puppet master pulling strings we can't even see. Our sun is a roaring furnace, a gigantic ball of plasma fusing hydrogen into helium at its core, releasing unimaginable amounts of energy in the process. But did you know it also vibrates like a giant bell? It's true. Stars aren't silent giants, they hum with a cosmic symphony. Deep within the sun's interior, pressure waves bounce around, created by the constant churn of hot plasma. These waves travel through the sun, causing its surface to pulsate ever so slightly. These pulsations are essentially sound waves, a stellar song if you will. But here's the catch, we can't hear it. Imagine a cloud so vast it could hold billions upon billions of Earth-sized planets. Now imagine that cloud isn't made of dust or gas, but of something a little more intoxicating. I'm talking about ethyl alcohol, the same stuff that gives beer and wine their kick. Deep in the heart of our galaxy, about 26,000 light-years away, lies Sagittarius B2, a giant molecular cloud so massive it dwarfs our entire solar system. And what's this behemoth made of? Well, among other things, a whole lot of booze. Now, before you start planning your interstellar pub crawl, let me clarify. We're not talking about a giant pool of liquid alcohol floating in space. Sagittarius B2 is a diffuse cloud spread out over a region 390 light-years wide. Imagine a sphere only 12 miles across, about the size of Manhattan, yet containing more mass than our entire sun. Now imagine this sphere spinning hundreds of times per second, its surface a chaotic maelstrom of gravity so intense it warps the very fabric of space and time. This, my friends, is a neutron star, the collapsed core of a massive star that exploded as a supernova. These stellar remnants are the densest objects in the known universe, their gravity so strong that a teaspoonful of neutron star material would weigh billions of tons on Earth. Think about that, a teaspoonful. It's mind-boggling. The reason for this incredible density lies in the way neutron stars are formed. When a massive star goes supernova, its outer layers are blasted into space, while its core collapses in on itself with unimaginable force. This collapse is so violent that it crushes protons and electrons together, forcing them to combine and form neutrons. We often think of time as a constant, an unwavering river flowing from past to future. But what if I told you that time is relative? That it can speed up or slow down depending on your speed and the strength of the gravitational field you're in. This isn't science fiction, it's Einstein's theory of general relativity, and it has some mind-bending implications. One of the most intriguing consequences of general relativity is time dilation, the idea that time passes slower in stronger gravitational fields. Imagine two identical clocks, one on Earth and one in orbit around a black hole, the ultimate cosmic drain where gravity is king. As time passes, the clock near the black hole will tick slower than the clock on Earth. The stronger the gravity, the slower time flows. This isn't just theoretical, it's been experimentally verified. Atomic clocks, accurate to within a fraction of a second over millions of years, have shown that time passes slightly slower at sea level than on top of a mountain, where gravity is slightly weaker. When we think of planets, we often picture them orbiting a star, bathed in its warmth and light. But scattered throughout our galaxy and likely countless others, are celestial nomads, worlds that roam the interstellar void without a sun to call their own. These are rogue planets, planetary orphans ejected from their star systems, flung into the darkness of interstellar space by gravitational interactions or the violent deaths of their parent stars. Imagine a world shrouded in perpetual night, its surface a frozen wasteland, its skies devoid of a familiar sun. It's a lonely picture, but rogue planets might be more common than we think. Astronomers estimate that there could be billions, perhaps even trillions, of these wandering worlds in our galaxy alone, outnumbering the stars themselves. Detecting these elusive wanderers is no easy feat. Without a star to illuminate them, rogue planets are incredibly faint and difficult to spot. We humans have a natural inclination to seek a center, a point of reference around which everything else revolves. But the universe, in its infinite vastness, defies this human-centric notion. You see, the universe doesn't have a center, at least not in the traditional sense. It's not like there's a giant cosmic signpost somewhere out there, marking the middle of everything. The universe isn't a sphere with a defined center. It's expanding outward in all directions at once, like dots on the surface of an inflating balloon. Imagine you're an ant living on the surface of that balloon. As the balloon inflates, every other dot appears to be moving away from you, regardless of your position on the balloon. You might be tempted to think you're at the center of the expansion, but so would every other ant on that balloon. The same principle applies to the universe. From singing stars to invisible matter, our universe is more alien and magnificent than most sci-fi. The more we learn, the weirder it gets. And that's the beauty of it all, isn't it? The universe isn't some static, predictable machine, it's a dynamic, ever-evolving tapestry woven from the threads of gravity, time, and matter. And maybe that's the point, to be curious, to keep exploring, because the universe isn't just out there, it's ours to understand. Every new discovery, every mind-blowing fact brings us one step closer to unraveling the grand cosmic mystery. If your mind is as blown as mine, hit that like button to help others discover the cosmos. Got a favorite space fact? Drop it in the comments. I read them all. And if you want more space explained in under 10 minutes, make sure to subscribe and turn on that notification bell.